Student, today we will learn the chapter differentiation. In the previous videos, we have already learned so many things: limit, continuity, meaning of differentiations, using first principles, so many formulas, and substitutions of trigonometrical formulas, and implicit functions. Before going to this topic, you have to first learn that topics. Now in this part we will describe use of log to differentiate. Okay, when and where we use of log, first we will understand the topic of the log, then we will start the use of log to differentiate here. Okay, and you know that a to the power m equal to n. And what do you mean by this? Is the exponential form. Okay, it is base, it is index, it is value. And now you can write a to the power m and n, means log of n at base a is equal to m. And you know the product formula of any base, that a base m into n, that you can write here at a base m plus log a base n. And you know the division formula of that is log at a base m minus log a base n. And also you know the m to the power n, you can write here log at a base m. Okay, and now you want to change the base of this, you can write a base c into log c base b. And also you can write a base b 1 upon log b base a. Using all this formula log, we will do the differentiation. Okay, and now one more things I want to explain you. If e to the power log e base x, this is equal, then whatever the value of you're getting here is 1, then this is equal to 1. Okay, now proof of this I will do it taking log both side at e base. If we are taking it and e base, we can write log e base x equal to log of e base x. And since to the power 1 equal to 2, so we can write to the power 1 equal to 2. So log of 2 at 2 base is equal to 1, means log of a at a base is always equal to 1. Okay, if these are equal, then it is 1. So now here log m to the power n, we can take here in log e base x into log e base e equal to log e base x. Now what is the value of here using this formula? That is 1. So log e base x. Now taking anti-log both side. Anti-log means whatever with the log, we have to take the opposite of that. So log is left here. What is the value of x? Equal to x. So we can say this value is x. Okay, so equal to x. Now so this value x, whatever is x. Okay, if here is minus 2, minus 3, plus 4, half something here, you have to write here power, and what is left here you can write in here. So why we use the log? We use the log for simplifying the some multiplication, divisions in a very easier way. Let we have to write here a to the power n into b to the power c upon d to the power n. If we are taking the log here, okay, so we can write directly here. These are in the product form, so it will be in a positive, it is negative, divide in negative, it will be in negative form, power will become here. So we can write n log a plus, here is we have written here c, so plus c log b. Here again we are writing here minus n log d. This way directly we will use the log in one line, not necessary to give the detail of this. Okay, using this log concept we will use the logarithmic differentiation, where one, if the question is in a multiplication form and division form, and also there are too much power, then we will use the log, and now using the composite function type we will solve the differentiate of this. Okay, and second things, we when get the variable to the power variable, either fx to the power fx or either fx to the power fgy, or this way if power is variable to the power variable we will getting anywhere, we will try to be taking the log both side, then we can say this will becomes here. Now for example y equal to x to the power x. Now differentiate it with respect to x. So now we are seeing here the power of the power is here. Okay, so now we will do dy by dx. Before doing this, what we have to do, if we take the differential this way, so we cannot use the formula here anywhere, x to the power n. We are the following power n, but we are x to the power x, so we cannot use the formula directly to doing this differentiate. Okay, so what we have to do, we have to do using log first, simplify using this way, then we can do these questions. So many students in starting taking the differentiate both side and using x to the power x, unfortunate we take this as equal to n, but it is not n, it is x. So don't do this way. Okay, now your question is y equal to x to the power x, variable to power variable. So you have to recognize that here we have to take the log both side. Log y equal to log x to the power x. Now we are not taking any base here, it means we are taking the base e. Okay, what is the base here? Base is here e. Now on differentiate both side as implicit functions, log y differentiate, that is y, but we are taking the differential of y, so we have to write dy by dx as implicit function. And this log we can be write x into log x, while x into log x, log m to the power n. Now differentiate of this x into log x, not differentiate of this, you have to differentiate of this. So 1 upon y dy by dx equal to, using multiplication formula, differential of x is 1 log x plus x, differential of log x is 1 upon x. Now you have to find dy by dx, therefore cross multiply, here is log x plus 1. Now putting the value of y, if y is not given in the questions, if you are writing y yourself, write here x to power x, that will be your answer. Okay, now the second method is y equal to x to the power x. Now we can write this form using this formula, e to the power x, x to the power x. Now x to the power x, we can take x here, e to the power x into log x. Now e to the power t, that is the composite function. So using the composite function e to the power t, the differential of this is e to the power t. Now differential we have to x log x. Now e to the power x log x is equal to this or equal to this directly, so we can write x to the power x, and using differential here, 1 differential of x into log x plus x, differential of x is 1 log x is 1 upon x. Now your answer is x to the power x log x plus 1. Okay student, so this way I have described you one questions by two ways. Okay, so you can do so many questions using both method. Any method you can take, either taking the log both side, or you can using the formula e to the power log e base x equal to x. You can solve it. In so many questions you have to take log 2 times. Okay, so let the question is y equal to x to the power x. Now if we want to be differentiate of this, find dy by dx. If you don't want to be take the log both side, we can use the formula. What is the formula? E to the power log e to the power x to the power x. Okay, so this x to the power x we are writing here, right, student? So now doing the differential of here dy by dx, differential of this is this one into differential of, we have to take this into differential of log x, that is 1 upon x, plus differential of e to the power x to the power x, x to the power x into 1 upon x, and plus differential of x to the power x into log x, and this can be written as again here x to the power x to the power x plus you can write here x to the power, this power you can subtract here, x to the power x minus 1 okay. So we can write here upon x. Now differential of it, this we have to do. So again we have to write it in the form of e to the power log e base x to the power x into log x to the power x to the power x, that is x to the power x upon x, plus we can write here e to the power x log x into log x. Okay, we can write here x to the power x to the power x, x to the power x upon x, plus log x and differentiation of this. That is e to the power x log x into 1 log x plus x into 1 upon x. This x is cancelled, and open this, we can write here this, we can write here again x to the power x, here is log x plus 1. Okay, so after simplifying this, if we want to take the common of x to the power x common, so what is left here? 1 upon x plus this one is common, and we can write here log x into log x plus 1. Okay, this is your required solution. Now again, if want to be take the log both sides, so taking log both side, you can use this way. Use here again x to the power x log x. Now again you have to take log both side. Log of log y equal to log of x to the power x into log x. You can check here total log x to the power x into log x. You have to take this way. Using log mn formula, you can write this way. Okay. Log of log x, and taking x here, log of log x. First you have to simplify this way. Now on differentiating both sides, log y, differential of log y, but it is a composite, so we have to do again the differential of log y, that is y, but it is implicit, so we have to write dy by dx. Now using multiplication formula here, differential of x is 1 log x plus x, differential of log x is 1 upon x. Now here is a composite function, differential of log x is log x. Okay, again it is composite, differential of log x is 1 upon x. This is cancelled. Now you want to find dy by dx, so dy by dx equal to, using cross multiply, y log y equal to log x plus 1 upon x log x. Okay, now putting the value of log y and y. Log y is, what is the value of log y? Log y is log x to the power, log y log x to the power x. Okay, y equal to x to the power x. So we can say that is equal to dy by dx equal to dy by dx equal to x to the power x, and log y is equal to log of x to the power x is equal to into log x plus 1 upon log x. Okay, so this you can write here log x to the power x log of log x plus 1 plus log x plus 1 upon x log x multiplied by log x. We can get here log x into log x plus 1 upon x. So this is your same answer. Okay, so whatever the method you will use, you have to use this very carefully, and you can use the formula also. You can use the formula of e log x also. Okay. So student, in this way you can do so many questions after proving using log method, and This method can be used in using the differentiations of infinite series, and this will be describe you in the next video. Okay, thank you for watching.